Okay, good day, whatever time it is that you guys are viewing this or deciding to view this video. Again, sorry about the not being able to come to class earlier because, well, as of recording right now, wala pa rin ako internet. For some reason, I don't know why that is. But anyway, yan, kita naman natin. Anyway, for now, what we'll be doing na lang, or what I'll be doing is that I'll be recording a video for all of fluid mechanics. And honestly, if kaya naman, if kaya ko naman, currently it is like what, midnight? If kaya ko rin naman, we can also do heat transfer so that next time that you guys come to class on Wednesday, at the very least, meron na kayong some prior knowledge about heat transfer as well. So, quick recap about fluid mechanics, right? Quick recap lang. What we will do, what we have done before is that we have explained or re-explained fluid pressure. If anything, we know this already from way before in thermo, right? But for redefinition purposes, right? The pressure of something, right? The pressure of a certain fluid depends on whatever pressure you're currently at, whatever pressure you're currently experiencing, plus or minus, depende na yan, sa rho g h, right? Sa density ng ating fluid times the gravity times the current height or depth, depending if you're going up or going down. Let me write that in white. PO plus rho g h, right? Rho g h. And then the thing here is that if your height increases, right? If your height increases, what happens to your pressure is that it decreases, right? And then opposite naman, right? If your height decreases, if ever your elevation or your altitude decreases, what happens is that your pressure increases, right? Baliktaran lang sila. Ganong klaseng relationship ang meron tayo between pressure and elevation or height, right? Some more basic definitions would include what density is, right? That's going to be the mass over the volume of any fluid. And then here we have specific weight as well, gamma, which is going to be the weight over the volume, or just rho g, right? Rho g. And then finally, we have your specific gravity, which is the density of a fluid divided by the density of a particular standard, which in this case, we take as water. Kaya magdali because, again, the density of water is very round at 1,000 kilograms per cubic meter. The newer one, right, the newer concept that we were introduced to last time was buoyancy, right? The thing is, normally, if you're interacting with a solid, what a solid can do is that it can impart a normal force. Usually, let's say, for example, this box, sabihin natin this box, right? This box has a certain mass. So, obviously, it would, right, exert a certain weight, right? Weight is equal to mass times gravity. If wala yung ground, right, if there were no object to contact, it would just fall, right? Excuse me. But because there is going to be something that supports this object, what it will do is that it will impose a counter force, what we call a normal force. Alam na natin ito from what do you call this? From free body diagrams, right? We've been drawing them for, I don't know, for me since high school, right? Something like that. What if, right? What if ngayon, ang mangyayari naman is that it were submerged in, or it will come into contact with something that was not solid, aka something that is liquid. Let's say, for example, this green thing is a liquid, right? This object will still exert weight, but now something else will support it, right? Another force will take its place. And now this isn't the normal force we're talking about. We are talking now about the buoyant force, right? And we need to clarify this definition, right? The buoyant force is now rho GV, or just, kung meron kayo, gamma V, right? So let's make the definition shorter. The buoyant force of a particular fluid is defined by the specific weight of the fluid times the volume. And this is where we get into this diversion. Pwede kasing dalawa, or there are two cases where you can apply the buoyant force. Both of them involves a fluid, right? But there are two kinds of ways that the fluid can be involved, right? And the distinction here is with the formula itself, right? The volume of what is the question. And the answer would be the volume of the fluid that was displaced. Kaya V disp tayo dito, right? That means there are two cases, right? Why are there two cases? Well, one is supposed to account for if the object you are supporting or that the fluid is supporting will float, and another if it will sink, right? Or another distinction would be, pwede namang nagfo-float yung bagay, pero if the object is, if the object is fully immersed, ibang bagay yan, right? And again, for the people who attended this class last time, right? What you can do is just look at this, right? We have ito yung same na na ginagawa natin before. You can have something, in this case, let's say for example a rock. You don't know if it has metal on it or whatever, right? And let's say for example, you just hang this rock up with a string. Let's say for example, yeah, may string dyan. Nakaganyan siya. Right? And now we know that the tension in the rope is currently, let's say for example, 3 newtons. Right? Sabihin na, okay, let's make it rounder. 10 newtons, ganyan. Right? Yeah. That means that 10 newtons should be roughly the same as the weight of the rock, right? Kasi nga the rock in this case, we assume, kasi nga wala namang ibang nangyayari dun sa rock, we assume that the rock is stationary because the forces that are acting upon it are in equilibrium, right? Kumbaga balanced sila. In this case now, let's say for example that the rock were fully submerged in a liquid. Let's say for example, tubig na lang, tubig, right? Water. And here's our vat of liquid. Yan. And now, halata raw in the experiment that now the rock, the same rock, let me try to see if I can draw it still the same. Probably not. Right? The same rock is still kumaga tied to the string, but now it appears that the string only holds, let's say for example, like 9 newtons. Saan napunta yung 1? Right? Saan napunta yung 1? That's the important part. Right? Kasi naman, it would be ridiculous to assume, or rather, it would be unfounded to assume that the rock's weight suddenly changed. It's not like the rock were disintegrating in the water. And mind you again, sorry, forgot to draw the rest of it. Right? This thing, or rather this drum, or kung ano man to, this is completely filled with water. So, ibig sabihin, right, that the rock is fully immersed or is fully parang wet with water, right? It's in the waters, it's under the water surface na, kumbaga, right? So that means the only conclusion that we can make is because of the influence of the fluid, meron na siyang magiging extra support. And in this case, the extra support will be our buoyant force. Yung 1 na natira, that means yun na yung contribution ni buoyant force. So now, let's just try to understand what's going on because, sasabihin ko pa lang, ang required dito is what is the density of the rock. Right? What is the density of the rock? Yun lang ang gusto nating malaman. Right? So now, let's just try to get the density of the rock right now. See if we can find it. Right? For you to get the density of the rock, you know the mass. You need to know the mass of the rock and the volume of the rock. Both of which, di pa natin alam. Right? So, where are we going to get the mass of the rock, the volume of the rock? Well, very easily, you know the weight of the rock. Right? Or you can find out, or you can deduce the weight of the rock. That's going to be 10 newtons, which is, by definition, mass times gravity. So what we can do is just 10 newtons is equal to whatever mass that is, let's assume is in kilogram, times 9.81 meter per second squared. Edi, lahat naman to tama, right? Newton is equal to kilogram times meter per second squared. Yan nasabi ni Newton sa kanyang second law. Right? So we will have 10 is equal to 9.81 times m. Kayo na bahala how you want to solve this. This would come out to be 1.019. The mass of this thing is 1.019 kilograms. Okay? So now we know the mass of the rock. Cool. 1.019 kilograms. Now, what about the volume of the rock? Well, now, in this case, saan pa ba tayo kukuha ng volume except for here? Right? And more specifically this, the buoyant force. The buoyant force in this case is defined by gamma F times V displaced. Right? We know the gamma of water. If you don't know, it's going to be, well, sulat ko muna. It's going to be 9.81 times 9.81 kilonewtons all over cubic meter. And now we don't know the volume displaced. Let's just assume that this thing is in cubic meters. And then now, cancel. You will see, parang may mali. Right? Ang mali is that, look, newtons, kilonewtons. That's not going to fly. So what we will do is that we will apply a conversion factor. Gusto nating gawin na magkapareho lang sila. So, turn the kilonewtons into newtons. Or, pwedeng baliktarin, okay rin lang naman. Right? We will now have 1 is equal to 9,810 times V displaced. Now, that V displaced will be equal to 0.01936. 9810 pala. 0.00, okay, you know what? 1.019 times 10 raised to negative 4, I think. Yes, negative 4. Times 10 raised to negative 4 cubic meters. So you can see, very interesting. Parang same na same lang talaga sila. And yes, tama naman talaga. You cancel, or just do this calculation. You will arrive at the following density. The density apparently is 10,000 kilogram per cubic meter, right? So as you can see, very heavy, right? For reference, the density of water, syempre, is 1,000. So this is 10 times as dense as water, right? I don't know what the density of steel is. I will hazard a guess and say it's what, like 7,000? Let me see, I'm just searching on my phone. Density of steel. Just so you guys know. The density of steel is... What is happening? Density of steel. It is 7. Oh, yeah, there you go. 7,750. The 7,850. So, a bit denser, a bit heavier than steel. Excuse me. So, there you go. And the lesson here is this. We tried this before, tas medyo mas malaki yung buoyant force. And as a result, dahil mas malaki yung buoyant force, we found out that it was less dense. Not as dense as 10,000, but like something like 3,000 ata yun. And now, that is our clue, right? The more the buoyant force is available, the more that it can provide a force that counters, right? The force that counters our rock or whatever sample it is. That means that the rock is going to be, right? That the rock is going to be lighter, right? Okay, so yun lang naman. Okay. Just hold on for a while. I will turn on the air conditioner. Wait. Okay, we're back. And now we'll go to the second parang case, which is when it's floating, right? Let's say, for example, you have here at the ocean, on the ocean surface, I suppose. we will have here a buoy, right? Buoy as in like yung lifeboat thing, right? There's a parang a lifeboat. There's a ano tawag doon? There's a lifesaver here, and then may ganyan, and then usually something like this. Basta a buoy is anything that floats on top of the water's surface, right? Usually this has like lights here. But let's say, for example, a very simplified version of a buoy. Let's just say, for example, that this thing is floating on top of the water. It takes on a cylindrical shape, right? And sabihin na natin something like that, right? And let's say, for example, that this thing has a diameter of 5, wag naman 5. Let's say 2 meters, right? If it has a diameter of 2 meters, ang gawin agad natin or gawin nyo agad is turn it into radius, right? Para mas madaling isipin. There you go. That's your radius of 1 meter. And now, let's say, for example, that this buoy is known to float. Right? This buoy is known to float. Now, let's say, for example, that the exposed part, right? The exposed part here is going to be, let's say, for example, 50 cm. At 50 cm. And at this point, right, yung sinasabi ko rin sa inyo, try as much as possible to standardize everything. So, kung naka-meters lahat, edi gawin yung meters. Kung naka-millimeters lahat, maybe that's more efficient or that's more, anong tayo ito? That serves your purpose just a little bit more, edi go ahead. Right? In this case, I would like for everything to be in meters. So, gagawin na lang natin na ganyan. Right? Now, let's say, for example, that sige na nga, let's use my true weight now. I used to say 75, but now I am 80 kilograms. Let's say an 80 kilogram man were to step on this buoy, right? Let's say, for example, that is me. And I have a mass of 80 kilograms. The question is, number one, right? Number one, how far down would the buoy sink? Right? How far down will the buoy sink? Just syempre, if I'm going to be there, then that buoy is just going to sink just a little bit further. Okay? Right? So, kumbaga, if this is the before and this is the after, syempre, it's clear to us, or hopefully it is clear to us, that there will be a change in the water, hindi nga water level just the level at which the buoy is still floating, right? Number two, right? How many people like me with a mass of 80 kilograms will it take for us to completely submerge the buoy, right? How many people? And letter C, if I were to step on a buoy that is also in the shape of a circle, how big, right? What does the diameter have to be for me to completely sink the circle alone? Right? How big? Right? So for example, merong mas maliit na buoy, right? It's floating 50 centimeters still, right? Ang mangyayari is that I step onto the buoy and immediately it sinks. How big does that have to be? Okay, how big does that have to be? So, we are saddled with a problem here. Let's try to begin. Let's try to think about it. Okay? Now, you guys do not see what the bottom of the buoy looks like. Right? And I also did not tell you the material of the buoy. I did not tell you the dimensions of the buoy. So, I'm going to have to convince you first and foremost that what we're going to do after is legit. Hindi siya yung parang being lazy, but in this case, it's just us skipping the first few steps. Let's say, for example, that we're going to take the side view of this thing. The side view of this thing. So, syempre, this is the water. And then this is the buoy. Ito yung ating 50 cm. And I don't know, right? I don't know how big the bottom is. But let's say, for example, ganyan yan. We don't know excuse me, we don't know the weight of the buoy. We don't know the mass of the buoy either. All we know is that syempre, as an object, it's supposed to have a certain weight. Now, the thing here is that even though we assume the buoy to be like rocking because of the sea or of the waves, ganyan, one thing remains correct in that the buoy is floating. Right? That means that hindi siya umaakyat, hindi siya bumababa. Right? It's not floating as in like actively floating up. Right? It's not also sinking. Right? I can step on it. So that means that this thing, right, needs to have a balanced force. In other words, right, because there's no solid naman that is acting upon this thing, right? Walang string on top, ganyan. There's no tension or whatever. There has to be an equal amount of buoyant force. And now here's the thing, right? We don't know nga the mass of this buoy. Okay, so this thing will forever remain a mystery to us. And number two, the buoyant force suggests that, dito tayo sa kabila. The buoyant force suggests that even if we know this thing is made of water, and sabihin na lang natin fresh water, ha? Right? Fresh water na lang ito for easier computation kasi ang seawater it's a bit denser at 1.05 and SG of 1.0 being 1.05 1.03, right? Even if we know this thing, it's very clear to us that we do not know the volume that was displaced, and in this case I can point it out to you but I don't know the value. Yun yung sinasabi ko, right? If I were to point it out to you here, right, this thing, the volume displaced would be this whole area right here that is under the water's surface. Kasi yan yung dinisplace ng object. Dati may tubig dyan. Now, nandyan na si object. That means that, well, that is the fluid that was displaced. That is the volume that was displaced by the fluid. So yun lang. Right? Hopefully, you guys understand what the distinction is when an object sinks versus when it floats. But the thing is, it's still unknown. We still don't know the volume that was displaced. For all we know, baka pala ang itsura niya ay, I don't know, something like this. Ganyan. Something like that. Right? Or baka ang itsura pala niya is SpongeBob. Right? But anyway, we do not need to know. All that we need to know is that the assumption is that it's floating. Right? Why does that matter so much? Because we are under the assumption that if you add more weight, aka the weight that comes from me as a person who weighs 80, right? As a person who weighs 80 kilograms, kailangan, because afterwards it's still floating, kumbaga, right? Kailangan ang mangyari ay floating pa rin. That means that there needs to be a certain amount, an equal amount of buoyant force there to support me. Right? If after ang lalabas is that nagfo-float pa rin naman si buoy, that means that the buoyant force that is there to support me or my weight must be equal to the weight that I'm exerting. Right? Hopefully that makes sense. My weight currently is 80 kilograms times 9.81. Let's turn that into newtons. 784.8. 784.8. Right? That should be my buoyant force, or the buoyant force that is there to support me. Right? Now, the buoyant force, which is also 784.8, right, is going to be gamma F times V displaced. Right? Very easy for us to find out kung ano yung gamma F. And again, the gamma F in here of water is 9.81 kilonewtons per meter cubed. In this case, we can turn it again to 9,810 kasi nga naka-meters yung ating measurement in here. And now we can find the volume that was displaced. Again, in cubic meter, testing lang natin. And now everything is correct. Lahat sila ay Newton. So we can just solve for the value of the volume that was displaced. The volume of that was displaced? The volume of the buoy. Because the buoy is the one that is in contact with the water. It's not like this is the volume of my body, right? That would be, I don't know how I would take that, but like that is the volume that was displaced kasi nandun ako, right? And now we can just get this 784.8 divided by 0.08 cubic meters. And as a result, right? And as a result, ang mangyayari is that we're supposed to find out not the density of the buoy, right? Although that would be nice, but we still don't know this, right? Ang kailangan na natin malaman ngayon is how far did it sink? What does this volume displaced mean in the first place ba? Right? This is the volume that was displaced, aka, di ba, syempre dahil tatapak tayo sa buoy, it will sink just a little bit. Right? It will sink just a little bit, and now that sinking, right, that additional sinking is what is responsible for the volume displaced. Kung ano man yung magiging volume nung bagay, nung part ng buoy na nag-sink because I stepped onto it, that will be the volume that was displaced. And now, if you look, this is just in the shape of a cylinder. So, ibig sabihin, this is just going to be pala pi r squared times height. Uy, height, yun na yung hinahanap natin. And now, our radius is just 1 meter. And then, hanapin natin si height. Right? So, honestly, at this point, pwede mo nang i-mano-mano ito. That will be 0.0254. 0.0254. This is in meters, or in this case, we can turn this into 2.54 cm. So that means that is how far I've gone down. Okay, that is how far I've gone down. Now, ito yung unang sagot. That means, how many people does it need for us, for kung sino man yung mga nakatayo on the buoy, for us to sink the buoy? Now, if you think about this, if you continue to add more people, right, they will continue to have 80 kilograms added every single time. Ikakahanap lang natin, we just got the answer that every time an 80 kilogram mass were put onto this object, excuse me, we would have 2.54 cm go down. So, ibig sabihin, feeling ko, madali naman na itong kunin. Right? How many people does it need to completely sink the buoy? Edi, 50 daw eh. Every single time that another person steps in, bababa by 2.54. Bababa, isa pa. So, for letter B, madali lang. 50 cm divided by 2.54 cm, we will have 19.68. 19.68. So, hindi naman pwede na 19.68 na katauhan ang pupunta doon. It would take the 20th person to make the buoy sink. So, that means my answer here, your answer here should be 20 people. Okay? And now, ito na ngayon. If I were to step on a smaller buoy, right? A way smaller buoy, again, still, ano siya? It's still 50 centimeters tall above the surface of the water. If I were to step on this buoy and it completely sinks or it completely immerses itself in liquid, does it mean it sinks, right? Kasi yung sinking, iba yun. It's a continuous way all the way down. If I were to measure the diameter, how big would that diameter be? In this case, parang pinaglalaroan na naman natin itong volume displaced. We needed such the volume displaced will completely go down after I step onto it, aka after we have that 784.8 newtons on top of the buoy. So in this case, ito lang naman ang papalitan natin. Right? You have 0.08 cubic meters is equal to pi times, ewan ko kung anong radius in meters. And then, 0.5 meters. This is the 50 centimeters that we were talking about earlier. Ayan. So now, again, pwede niyong imano-mano ito. Right? We will have a radius of 0.2256. 2257. 0.2257 meters, or in this case, 22.57 cm. Parang napakaliit nito, even for me, I think. What is 20 cm? That's not even bigger than a ruler, right? So smaller than a ruler. Yeah. So very small, right? Suffice to say. Now, that's it. That's our question, right? And that is it for buoyancy. So for buoyancy, you're really just going to have to play with the values, right? The values, or rather the volume displaced. Yun lang talaga yun. Right? That's the important bit. Okay? Now, conservation of mass. We were moving on to conservation of mass. And now the thing is this. Let's say, for example, just close your eyes for a little bit. Imagine mo that there is you have a tank. Yun, may tangke ka ng tubig. Let's say, for example, you put in, for every second, right, meron kang gripo going towards the inside of the, of the tank. And every second, 3 liters of water starts pouring into the tank. Every second, may 3 litro na pupunta doon sa tangke. That's a lot, right? Just so you guys know, right? Isipin natin, right? I can't even pour a liter of water in 1 second. I feel like that would be way too fast, right? And imagine, let's say, for example, 4, right? 4 liters of water. You turn on a faucet for the tank that spits out 4 liters of water every second. So kumbaga, the rate at which you introduce water cannot match the rate at which you let water leave your tank. That's something to think about. The acceptable conclusion there would be na babawasan ako ng tubig sa tangke. Because yung inflow ko, mas marami sa outflow ko. Feeling ko naman you guys understand, right? Vice versa, if for example, 4 liters of water ang papasok every second, and then 3 liters ang lalabas every second, that means that your tank is getting fuller, right? Umaakit ang water level because you have more inflow than outflow, which is what I would like to what I like to have for my personal finances, something like that, right? If, for example, the same amount were going in and out, this is an introduction as to what we want, or what is the yung kailangan, the requirement for our next topic, which is conservation of mass. That system, or rather that that instance, is what we call steady flow, right? Steady flow. Very, very creative name, right? Steady flow. Steady flow. Right? Steady flow happens when basically the amount of stuff going into a system is the same, not just roughly the same, not ganito ganyan, but the same as the thing going out of the system. Same in, right? Same in, and then dapat same out. That is the important bit here, right? If the same stuff goes in every second, if the same stuff goes out every second, not pala same stuff, but more like the same amount of stuff goes in, same amount of stuff goes out, we can apply steady flow. This is another parang connected term for conservation of mass, which basically states that mass is conserved. You cannot make, right? You cannot make or remove, right? Mass. You cannot create nor destroy mass. You can only transfer it. Oops. You can only transfer it from one location to another. And when we're talking about steady flow, yun basically, when we say amount of stuff going in, dapat, yun, the amount of mass going in, given a certain amount of time, we'll just call this delta T for now, should be or should match the same amount of mass going out in the same time span. Kumbaga, kung ano papasok, yun ang lalabas. Right? Very clear. And in this case, this is actually something that we know the name of. This is what we call mass flow rate. Mass flow rate. Literally, how much mass flows through an object at any given at any given time. Right? We denote this with the letter M with a dot on top. M in is equal to M out. And based on our definition of density, it's going to be mass over velocity. Ayan tuloy. Mass over volume. Right? Another definition of mass would be, therefore, rho times V. Right? Density times volume. And now, hindi lang basta-bastang volume at mass ang pwede for our density. If you imagine this for density, let's say for example, ganyan, may M, tsaka may V, we can divide or multiply both sides by 1 over time and then 1 over time. Wala akong ginagalaw. Wala akong masamang ginagawa. But basically, we will have mass over time all over volume over time. We know the definition of this already. This is our mass flow rate. And there is also something the same as for volume. This is what we call volume flow rate. Currently, I write it as V with a strike through in the middle because medyo nakakalito kung ano ito. Right? Or at the very least, in the mechanical engineering department, we just like to call it either V with a slash or, or later down the line, letter Q. Pero kasi, something has already taken the place of Q. We will talk about that later. Kaya ganito na lang ang ating pagsusulat ng volume flow rate. Okay? Volume flow rate. Volume flow rate. Now, let's try to explore what this means. Kung mass in is equal to mass out, what can also happen is that mass flow rate is equal to density times volume flow rate. So in this case, pwede natin siyang isulat, pwede nating pahabain, something like this. So you might say to yourself, bakit papahabaan ko pa? Right? The thing about this is that there are two distinctions of how you can use conservation of mass, right? Whenever something is in steady flow, right? And usually the problems that I will give you will be in steady flow unless I specifically tell you to do so, right? It can be used two different ways. Number one, you can use it for liquids, and number two, you can use this for gases, right? It doesn't work the same way for solids because, well, solids don't flow. Yun na lang, sabihin na lang natin, right? Excuse me. Now, we can use this two different ways. Let's first start with yung liquids. Liquids are what we call incompressible. Right? In this case, ang incompressible, ibig sabihin, cannot be compressed. Right? But let's think about the implications of that. If you cannot compress an object or basta anything, you cannot mess with its volume, basically. When I compress something, right? When I compress something, I am lowering its volume kasi kino-compress ko siya. Right? But if something is incompressible, what you will do is you will not change its volume. And here's the thing, right? The thing is that density is equal to mass over volume. Siyempre, kakasabi nga lang natin with conservation mass that the amount of stuff going in should be the amount of stuff going out. So same si mass. Eh kung sinabi natin that incompressible siya, aka you cannot compress it, aka you cannot change its volume, look at this. They're both going to remain the same. The implication, therefore, is this. Any kind of incompressible fluid does not change its density. Imagine yun, right? how would you be able to change the density of something? Either you add more stuff to it, aka increase the mass but keep the volume as is, or, right? Basta, sabihin mo lang na liliitan ko yung volume. But in this case, you cannot do that, right? You cannot change the volume of this because nga it's incompressible. Therefore, itong in tsaka yung out, pwede mong i-cancel. Now, you will be left with something like the volume flow rate going in should be equal to the volume flow rate going out. Ang kaibahan nito with gases is that there is no such thing. You need to do both. Kumbaga, need to do both. And now, right? Let us define what V slash is, what volume flow rate is, using this diagram. Let's say, for example, we have here a pipe that has water na lang para mabilis. Say, for example, we have this pipe and then there is a large version of the pipe. Now there is a smaller version of the pipe. Halata naman at this instance, at this junction, the pipe is quite large. Okay? The pipe is quite large. Let's say, for example, let's denote the area as A1. This is now going to be our state 1, our location 1. Let's say naman here for number 2, we're going to have a much smaller, right? A much smaller area, right? Let's say, for example, this is area 2. Now, let's say, for example, that this pipe is completely this pipe is completely flowing with liquid, with water, with whatever. We know that this is a liquid. So in this case, let's try to unpause. Sabihin na natin, we know that there's water flowing. Kumbaga, ganyan yung tubig, blah, blah, blah. Right? And now, let's take into account, kumbaga, shadean natin. Let's try to analyze the behavior of these two, right? Of these two slices of water. Ang gagawin ko is that, kumbaga, alam niyo yung para sa YouTube, pag naghahanap kayo ng particular moment inside of a YouTube video, what you do is you play and then pause agad. Right? Let's just let it play for 1 second and then pause it agad. Right? Let's say we pause, we play, and then we pause. Eto, makikita natin, this thing has now moved just a little bit closer right here. Right? Ito na yung bago. And now what you guys notice, right? Oh, kumbaga, it traveled from here all the way here. Right? This is area 1. And now that area, that slice of water has now traveled to all the way here. Right? Kumbaga, this is after 1 second. After 1 second. Now, what do you guys think will happen here? Dahil sabi nga natin, the conservation of volume states that for liquids, the amount of volume that goes in must be the amount of volume that's going out. Ibig sabihin, this has some volume, and ibig sabihin, this A2 has to match that given volume as well. This is why now, look at this. It's much faster. Kumbaga, makikita nyo that it has traveled way farther than just our original, right? Our original work. Right? In this case, both of them need to have the same volume. That is why itong si state 2, itong si location 2, it has to kumbaga compensate because we know that the volume swept by the thing going in must be the same as the volume swept going out. Right? So in this case, now I can show you that the volume flow rate, which is basically just the amount of volume going in a given amount of time, is going to be the volume out going at the same amount of time. And then now we can see here that, wait a second, this is just another cylinder. These are just bunches of cylinders. That's just going to be the area going in times the length going in. Right? Ano yung length? Ito. This one. Right here. And now that should be equal to the area going out times the length going out. And again, here, alam na natin, it's this thing. Right? Kung gaano yan kahaba, all over time. And now, if we rearrange this, ang gagawin ko, hihiwalayin ko si A in, tsaka si L in, pati itong si delta T, and then itong si A out, and then itong si L out, all over delta T. Now, do you guys notice something? This should sound familiar. These two both should sound familiar because it's the amount of length you've traveled over a given time. That is just the same as velocity. That it means A in times vel in is equal to A out times vel out. This is our conclusion for the conservation mass. Right? Ibig sabihin nito is that A in, the area going in, times the velocity going in, should just be equal to the area going out times the velocity going up. This is what explains, yun nga, kapag meron kayong hawak na hose, tapos you constrict the end of the hose, and ang mangyayari is that the hose will now have its water travel faster. Right? That is the mechanism behind that thing that we used to do as a kid. And eto na nga, ang ibig sabihin din nito, another parang separate conclusion would be that your volume flow rate is equal to your area times your velocity. And that means we can use this here. This one is just a more general definition wherein yung rho going in times area going in times velocity going in is equal to the rho going out times the A going out times the velocity going out. Yan lang yun. Right? So very simple. You just have to know, I suppose, different area examples or formulas. Yun lang. Right? Okay. Very simple. Let's say, for example, right, para meron tayong example at the very least before we end, so malapit ang mag 1 hour, or actually we can take this further, we can just finish with Bernoulli's principle, right? Let's say, for example, air grills. Ito lang, isa lang yung ano ko dito, isa lang yung example ko kasi nga, medyo understandable naman siya, hopefully. Right? Let's say, for example, an air duct, right, is like this. And then let's say, for example, that it encounters a restriction such that ang lalabas na ngayon is that you will have a smaller outlet. Ang smaller outlet na natin ngayon is still in the shape of a rectangle, but now things are a bit different. Right? Ayan, let's say, for example, ganyan yung itsura. Yeah. Let's say, for example, that this thing, right, this air entrance, air duct, has dimensions of, let's say, for example, I'm just making stuff up, as we go along. Let's say, for example, 30 cm by, let's say, for example, 45 cm. Tapos, ang labas naman ngayon, right, ang panglabas niya, it should be, I don't know, something like 20 cm by 15 cm. This is air, mind you. This is the air that we're talking about. And air, let's say, for example, flows in, right? Flows in with the velocity of, let's say, for example, 0.7 meters per second. In this case, let's also assume, ito na, ang daming assumption, no? That the density of air going in, right, going in is going to be, I don't know, let's say, for example, 1.2 kilogram per meter cubed. And I suppose, at this rate, kapag paglabas ng ating air, mineasure mo ulit, and now the amount of air, or kumbaga the density of air going out is now 1.15, right? Kilograms per cubic meter. Now, our goal is to find out how fast the air is going out of the duct, right? Yun ang ating hinahanap. And in this case, feeling ko nga, even just like looking at this thing, oops, sorry, kailangan vel out pala, vel out. Makikita nyo na what you need to do. Hopefully, makikita nyo na what you need to do. I'll give you a few seconds to think about it, but ang daming given, right? And the given is supposed to tell you something already, right? Sadly, hindi ko kayo matuturuan ng ideal gas equation, so I can't give you parang more complicated what do you call this, pieces of given information. Ang kailangan lang talaga natin is we need to recognize that air is a gas. As a result, we can use, right? We can use conservation of mass. Rho in, A in, vel in. Is equal to rho out, A out, vel out. That's it. Right? That's it. And now, ang gagawin na lang natin is let's just plug things in. Right? 1.2 kilograms per cubic meter times area. Ang area natin naka centimeters. Might as well turn that into meters already. 0.45 m. Tapos, itong velocity going in is 0.7 meters per second. Now, let's just clean up. Meter, meter, meter. May tatlong meter. Tanggal. We will have kilograms per second, which is indeed mass flow rate. Now we go out 1.15 times kilograms per cubic meter times 0.20 meters times 0.15 meters times, ito na yung hinahanap natin, yung vel out in meters per second. And again, makikita natin na same lang ang ating mga units. Kilograms per second, kilograms per second. We can begin just putting in the numbers if you would like. If we just put all of this together in our calculator, we should be able to get the answer already. Oh, magme-memorize pa ako. 1.2, 30, 45 times 0.7. Ay! Times 0.7 all over 1.15. Yeah. 1.15 times 20 times 15, we will get, para may kulang. Oh, sorry, hindi pa siya naka-point. Yeah, it's now 3.287 or 3.29. That means that your velocity here, I have to say, is very fast. Right? So, medyo mali na nag-invento lang ako ng mga givens. Right? But hopefully you guys understand what's going on here. Literally, because wala naman sinabing may tagas, right? There's no leak in the air duct. Whatever air that comes in into the air duct must come out as well. Okay. Now we've done this part. So medyo okay na tayo dito. We will now go to our last part in fluid mechanics, which is Bernoulli's equation. And sorry to disappoint, pero I think we've already learned this before, right? And okay, I'm pretty confident we have learned this before, but here's the thing. Bernoulli's equation is one of the parang crowning achievements of the people in their time. I don't know which Bernoulli has made Bernoulli's principle. Basta the Bernoullis are a prolific family of mathematicians, scientists, whatever. Actually, hanapin ko kung sinong nagsulat ng Bernoulli's principle. I am betting on Jacob Bernoulli. Tama ba? Sino ba ang una? Oh, it's Daniel Bernoulli. Ah, oh well. Sige. Although Bernoulli deduced that pressure decreases when the flow speed increases, it was Leonhard Euler. Oh. It was Leonhard Euler in 1752, so it's very old, who derived Bernoulli's equation in its usual form. So apparently, ang ginawa lang ni Daniel Bernoulli was that he noticed that pressure and speed were opposites of each other. So let's try to unpack that. What's happening? Bernoulli's principle, very disappointingly, hindi man disappointing, but like we see this everywhere. There is no more ubiquitous of an equation than the conservation of energy. The thing about conservation of energy is that it does not need to follow any parang requirement na parang kailangan ganito muna before you apply conservation of energy. No. The thing is, this is valid everywhere. Right? This is valid everywhere. Energy is not created nor destroyed. It can neither be created nor destroyed. It can only be held or stored or transferred to other things or beings. Right? And Bernoulli's principle is a restatement nga of conservation of energy. Kaya siya boring-ish. But it's not really boring here. In this case, Bernoulli's principle, it talks about three different things. Three different things. What we have here is the kinetic energy, the potential energy, and then the enthalpy. If you guys remember about enthalpy, right? Ito dapat daw yung magiging, sorry, let me cut my my train of thought off there for a second. Basta itong tatlong ito, these are all forms of energy. And ibig sabihin nila Euler, nila Bernoulli is that before and after a state, it must still contain these three things together. So in this case, I'd like to kumbaga show this to you. Kumbaga the KE going in plus the PE going in plus the H going in should be equal to the KE going out plus the PE going out plus the H going out. The thing about this now is that I have to clarify a couple of things. First, madali lang yung kinetic energy. 1/2 mV squared. Madali din lang yung potential energy. mgh lang. Literal lang yan. Right? I'm doing a subscript of 1 for the things that come before. Ito na lang. H1. H1 is enthalpy in the beginning. And now I will write down here, kumbaga, kung anong relationship ng enthalpy sa isa pang bagay na alam na natin before, which is internal energy. Internal energy is how hot something is. Kumbaga, right? It is the total amount of energy na hindi na-detect ni kinetic energy, pati ni potential energy. Even if I sit here, lie down, do nothing, right? I'm still giving away energy. Even if I don't move, aka my velocity is equal to 0, I'm not gaining or losing altitude. So walang difference in potential energy. Ngayon, yung kung ano man natitira, which usually in this case would be the temperature of the object or basta of the fluid, yan ang relationship nila, H is equal to U plus what we call flow energy. Flow energy is equal to pressure times volume. And some tuty of mine has asked before, so sir, isn't it just kinetic energy? Right? Flow kasi, it means something related with motion. Right? But let me define flow energy right now. It's the amount of energy you need to suck something. Using a certain amount of pressure difference, how much energy you need to take to suck something in or to blow something out. So it's either going to be PV, right? How much air or how much volume did you suck in or blow out? And then your P is basically what is the pressure difference. Kung saan ka versus kung saan yung object na blinow mo or sinak mo, right? That will be flow energy. And in this case, if we think about it, in a normal PVC, kumbaga, in just like any normal parang household, hindi naman umiinit or lumalamig ang ating mga pipes. And in that case, that means as well that the amount of hotness, kumbaga, or rather the most uh, known for temperature should not be here. What do I mean should not be here? Kumbaga, if we're going to now put this all together, ito ay dapat U1 plus P1V1. Right? Or masyado ng sige, V na lang. Sige, V1 na lang. Sige, V na. Yan. This is also going to be U2 plus P2V. And ito na yung problema. Right? Or hindi naman problema, but more like the conclusion is that U1 and U2, right? U1 and U2 are both, anong tawag nito? U1 and U2 are both the same. How can I know they're the same even without like giving us the full formula for Bernoulli's principle? It's because they have the same temperature roughly. Right? Hindi naman magbabago ang temperature ng pipe mo in the beginning or in the end. Siguro mangyayari pa yun because like the water, the shower water is being heated by the heat outside, blah, 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 blah. Okay lang yun. Pwede yun. Sige, I'll take that example. And ang matitira sa atin basically is dahil wala na tong dalawang ito, P1V, and then, let me do this again. GH2 plus P2V. Yan ang ating full equation for Bernoulli's principle, pero ito yung pinaka mega ultra basic. Right? Why is this basic? Because, well, this is still in terms of energy. We are now going to turn this all into being based by pressure by means of dividing by volume. Kayo na bahala how you're going to divide the volume, but ako, I will choose to put it like this. 1/2 M over V vel 1 squared plus, again, M over V GH1 plus, in this case, tatanggalin ko lang yung volume. Just P1 is equal to 1/2. Again, MV vel 1 squared plus, we'll keep going, M over V GH2 plus P2, yun lang. And now, some profs, they rewrite this, ginagawa nila, pinagpapalit nila yung dalawa. Okay din lang naman sa akin. But now, all of the highlighted things in here are supposed to be rho. So, if you don't want that, edi, tanggalin mo na lang. Right? Or, in this case, just continue having it there. If it doesn't necessarily obstruct whatever it is you're doing. And ito yung sinasabi ko kanina, right? Na usually, what they prefer is something like this. Inuuna nila yung head, right? Inuuna nila yung head, yung pressure. So, sorry, medyo technical yung ating definition for head. I should not be using that. Ang ginagawa nila is everything is now in terms of, right? In terms of pressure, right? We know this one already from earlier. Rho GH. We know this thing from earlier as well. 1/2 rho vel squared. And this thing as well, pressure. Actually, hindi pa natin to alam. So, let me try that out now. Here's the thing. Kilogram per cubic meter. And now, this is meter per second. Pero naka-squared. The meter squared per second squared. Now, what I will do is something like, I will charge my laptop first. Okay, there you go. Ang gagawin ko ngayon is that I will remove, oh my goodness. I will remove this square. Ang gagawin ko is that ipapatong ko lang dito. Why am I doing that? Because look at this. Kilogram meter per second squared. Again, we know this. This is a mass. This is an acceleration. So what you need is a Newton here. Right? Newton. And then, merong isang M sa taas. 3 sa baba. So that gives our value back to Newton per meters squared or Pascal, right? Now, we have that put together. What's left is for us to use Bernoulli's equation, right? Yun na lang talaga. And I don't know how many I'll do. Siguro dalawa na lang. Dalawa. I want to show you guys something cool. Right? So in this case ngayon, let's have let's say a tank. Or actually, let me just drink water first. I'll be back. All right. I'm back. Where were we? Yes, here, right? So we've found out, rather we've established that 1/2 rho of L squared is still going to be in terms of pressure, right? This is still newtons per meter squared. That's still Pascal, and we can now proceed to our first example, which again I will make off the top of my head. Let's say, for example, that we will have a tank, right? A big tank. I'm not going to tell how big the tank is going to be. But let's say, for example, that the tank, excuse me, has an open top. And that is the important thing about this exercise or this example. I don't know how tall this tank. Oh, sorry. I don't know the other dimensions of this tank. All I know is that it has a certain height to it. Okay? So for example, this is our tank. Yeah, meron tayong mga gradations or something. I don't know. Right? Let's say for example, this tank is a whopping 5 meters tall. Very tall tank. Right? And at the bottom of it, right? And at the bottom of it, we will have, or hindi nga at the bottom, you know what? Let's make this more interesting. Let's say, for example, that there's going to be a spout of water, right? Or a hole that you're going to unplug here, right? Let's say, for example, ganyan, 5 meters yan. And now this, ano here, this hole right here is just 1 meter tall, right? Of course, if you're going to unplug this, right, water will shoot out, right? And let's say, for example, this tank is full. Right? Let's say this tank is full. And again, it is open. Right? The top is open. That is the important thing. Now, how fast? How fast is the water flowing out of out of this out of this spout at the bottom, right? Why is it called J? It's because it's called a jet, right? Any jet of water, kumbaga, right? And so you might be thinking to yourself, like, you've clearly given us not enough information, right? It seems parang ridiculous that with just 5 meters, 1 meter, open, blah, 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 it seems like tapos na, right? Is this possible? Oops. Okay. Right? Is this possible now? The answer is yes. Syempre, ako nga nagbigay, right? And the thing about this is that it's a this is why a lot of people enjoy, or rather take pleasure in not in solving fluid mechanics questions, but more like when they use Bernoulli's equation, it's always an interesting time, because if you're going to write down everything, and most specifically yun nga, we will write it down like this, what you're going to do afterwards is the fun part, right? It seems like currently there are 6, right? There are 6 things, or there are 6 terms that you need to take care of, diba? So it seems like, oh my gosh, there's so many things to think about. Let's say, for example, let's just count all of the variables. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 variables to think about. There are 6 terms. It seems so impossible. Kumbaga. But the thing about Bernoulli's equation is this. Number 1, for you to use it, right? For you to use it, you need to have the same, kumbaga, the same, what do you call this? Fluid, yan. You need to have the same fluid. If this part here, right? If this part here contains fluid water, and this part here contains oil, parang hindi na yun the same, Right? Because, let's say for example, ito, iba na yan. Yung mga P dyan, yung mga rho dyan, iba na yan. Right? So, kaya dapat same yung ating fluid. Next, what's supposed to happen is, well, yun lang. I think, I don't want to go into the specifics of things right now, but that's the only other thing that you need to take care of. Right? This is why people enjoy, yan, babalik na tayo dun sa point na yun. This is why people enjoy to do the solution to a Bernoulli equation problem is because you're not, almost all of the time, you will not be using all six. Although I will be showing you what the full six looks like in like a problem set I will publish soon. But look at this. Right? In this case, we usually employ gauge pressure tayo, ha? All of the pressures here should be in gauge. And most specifically, I'm only saying this because we have here values of P1 and P2. How are you going to use the Bernoulli equation or the Bernoulli's principle? You need to select two locations. In this case, dalawa lang naman ang locations of interest, aka, palagi ko na sinasabi earlier, right, that there is an open top to this thing. So we will call this state 1. And this naman, well, this is the thing we need to find. This is going to be state 3. Now, here's the thing. In state 1, what is the pressure? You might say to yourself, okay, it's on the surface of the water. It's experiencing atmospheric pressure. You'd be correct, yes. But in this case, kasi we are doing gauge pressure. So, immediately, P1 is 0. Tanggal na agad ang P1. Because anytime you see something touch or be open to the atmosphere, that means it is experiencing atmospheric pressure. Okay? Next, rho GH. Rho GH1. Saan natin yan makukuha? Well, height in here, it feels directionless. And that is correct. In the sense that kapag kailangan mo ng height, kailangan mo ng reference point. I am 5'6.5". With respect to what? Well, with respect to the ground, of course. So in this case, what we need to do is we need to create a reference point. In this point, syempre, makes sense, itong nasa ilalim. Right? The one at the bottom. So if we create our reference at the bottom, it would make sense that the height of our stuff, of our tank, is going to be 5 meters tall. So pwede na nating ilagay dito 1,000 times 9.81 times height 1, which is 5, plus 1/2 rho 1,000 times vel squared. Na ito na yung vel ko. Ito na yung vel squared natin. What is the speed at which the water in specific in location 1, how fast is the water flowing there? And that might be a tough question to say. You might say, oh, something really small. Say it's really slow when it's going down. And I would agree with you, yes. The thing is, ayokong ibigay kung ano yung magiging, hold on. Kung ano yung magiging dimensions ng ating tank, because this is what we're supposed to call a reservoir. A reservoir, basically, is imbakan lang ng tubig, right? Imbakan ng kahit na anong fluid. And in this case, a reservoir, if it's large enough, this water will flow so slowly. But honestly, you can just make it negligible. Right? Because this vel 1 is so slow. Let's say, for example, 0.01. Is squared mo pa yan. Liliit pa yan lalo. 0.01 squared. Liliit pa lang lalo. Right? So, that kind of endeavor as to how you're going to estimate is useless. Paliit lang yan ng paliit. It does not matter. And so, as you can see here, sa side on the left, isa lang nagamit natin. Let's see, for example, let's see kung ano mga gamit natin sa right. Sa right naman, we will have P2. What is the state or what is the pressure at location 2? Bakit 3 ito? Okay, sige. Balik natin sa 2. Anyway, anong pressure 2? Well, again, this jet is exposed. There, that means ditanggal. Right? Rho GH. Oh, we've seen this before. Again, with respect to the bottom, that means that the height of that thing will be 1 meter tall. And then finally, ito na yung hinahanap natin, 1/2 times 1,000 Bell squared. Ito na yun. Right? Yun yung hinahanap natin, the velocity of this jet of water. You know what? Let's make it Bell J. Right? And now, if you see, everything in here is 1,000. Edi tanggalin na natin. And then, ililipat natin ito sa kabila. You will see both of them have 9.81. Edi, i-group ko na lang. 9.81 times 5 minus 1 is equal to 1/2 times 1,000. 1/2 times Bell J squared. And lipat ko lang si 2 dun sa kabila. We will have Bell J squared is equal to 2 times 9.81 times 5 minus 1. And for us to remove this squared, kailangan naka-square root. And now, we just calculate. Square root of 2 times 9.81 times 5 minus 1 is 4. So we will have 8.858 or 8.86. 8.8. That is fast. 8.86 meters squared. Meters per second. Okay? So that is the stream of water that we have. And actually, this is something that is a subset or parang is a sub-property or a property that you can see from Bernoulli's principle is that if you're in this situation, the top is open, it's a reservoir, so water flows really, really slowly here, and you have this. What you're going to do is, this is actually called Torricelli's law. Torricelli's law. And what Torricelli's law states is basically for you to find the velocity of this jet, velocity of just this jet from this reservoir whose top is open is basically square root of 2g and then delta h. Delta h here basically means kung gaano katangkad yung faucet, pati yung, the height difference between the faucet and then the top of the reservoir. So in this case, tama tayo. 2 times 9.81 times 5 minus 1. That is Torricelli's law. Velocity is equal to square root of 2g times delta h. Okay? Now, finally, ito na, bubuuin ko na. Right? We will have, let's say, for example, sige, ganyan na lang. Let's say, for example, we have created the piping system of a random home. We have here a constant diameter pipe. Let's say, for example, dalawang apartment. Yung isa nasa first floor, yung isa nasa second floor. We have a constant diameter pipe in here. And I am sure, right? Ay, hindi nga eh. Gawin na lang natin is let's have this as a part of a wall. Let's have this as part of a wall. Ayan. Tapos, this is actually a reservoir. Right? Another reservoir wherein nagpupur ka lang ng tubig. Nagpupur ka lang ng tubig like this. Right? And now, the thing is that this, This height difference, because we can see or we can perceive a height difference here, this is actually going to be, let's say for example, 2 meters na lang, 2 meters. Right? 2 meters. And now, what we're supposed to do is try to find basically how much pressure is in this section. Right? This is a gauge. Right? May gauge na tayo. Basically, ang tinatanong ng tanong is how much pressure does there need to be in this bottom region so that we can successfully deliver water in here. So, you might think to yourself, okay, again, ito na naman tayo. Meron na naman tayong parang problem wherein isa lang yung given. So, anong gagawin ko dito? Right? Well, again, ginagawa natin just like before is we just type tuloy. We just put everything out there. 1/2 rho vel 1 squared is equal to P2 plus rho G H2 plus 1/2 rho vel 2 squared. Now we will have this again and again. Okay, ito na tayo ha. Let's just try and estimate tuloy. Let's try and identify which states or which locations we would like to have. Syempre, ito, kailangan natin yan. And then, ito, syempre, ito yung isang malaking clue din, number 2. Okay? Now, P1. What is the pressure at P1? That's the thing exactly that we're trying to understand. Now, anong height at state 1? And again, we can define it where you would like it to be. Right now, para hindi na natin pahirapan sarili natin, let's just take the beginning, the bottom to be wherever state 1 is. Hindi, easy lang. Tanggalin ko yan. Kasi ang height ng state 1 is 0. It's at the bottom eh. Right? Next. Right? We will have this 1/2 rho. I know that's 1/2 times 1,000 times vel 1 squared. Okay? And now P2, because it's exposed to the atmosphere, dapat 0. And now the height of this thing is clear as well. 1,000. 9.81 times 2 meters. And now this again. 1/2 rho vel 2. And prior to this, wala naman tayong pinag-usapan. So now, parang kulang. Right? Kulang talaga ang given kasi hindi ko na alam kung ano value ng velocity. Hindi ko rin alam kung anong value ng velocity at state 1. Ibig sabihin, hindi ko rin alam at state 2. But the thing about this is that we are still not using one of our given parang pieces of information, which is the constant diameter. In this case, constant diameter, I'd like to convince you that these guys, or rather, you don't need the values of vel 1 and vel 2. Right? What do you mean? In this case, in the most general case, whatever goes in must come out. Yun ang ibig sabihin ng ating conservation of mass, and basically, that's what we've been doing. Right? Sabi natin, palakihin natin ang ating definition. We'll have density in, velocity, volume flow rate in is equal to density out, volume flow rate out. Edi, right? We continue. This is water we're talking about. Edi, tanggalin natin ang density going in and out. And let's transfer this to A in vel in is equal to A out vel out. Yeah, yan na ngayon. Right? And now here's the thing. If they have the constant diameter, that would mean that their area going in would be equal to their area going out. Eh kung same lang naman sila ng diameter, ibig sabihin same sila ng circle, and that circle has the same area. Ito yun. That means that the velocity going in, aka vel 1, should be the velocity going out, aka vel 2, aka you don't need this. You don't need this. Why? Because they are the same. We are now left with this very simple, diba? Very simple equation. 1,000 kilograms per cubic meter times 9.81 meter per second squared times 2 meters. And now, again, we will have, right, itong tatlong ito, kilogram meter per second squared, that is Newton. We have an M in here and an M in here sa baba. So, dapat Newton per square meter or Pascal. We are talking about Pascals. And now, this will be 19,620 pascals, or in this case, or 19.62 kilopascal. So you're up there. You're getting up there. It's somewhat of a large pressure already. But by no means yung really, really high, really dangerously high. If anything, masasakit lang ulo mo dyan. And now, look, Bernoulli's equation is all-encompassing because of the fact that we are drawing upon conservation of energy, a thing that is universally true. Notice nyo ba what this equation looks like? Hopefully, you have, because it really is the same thing as our first equation, rho GH. It really is just rho GH at this point. Right? Yun ang ating closer for Bernoulli's principle. There are lots of different ways that you can remove or that you can cancel these values. Just make sure that they are correct. Kumbaga, right? So that is it. That's also something I want you guys to learn, or something I want you guys to remember kapag constant diameter, right? So hopefully these examples are good enough for you to help hone your intuition. And again, magpapa-problem set din naman ako para may masagutan kayo in the meantime. Okay? So that's everything so far. Thank you very much for deciding to watch this. Ayun, sakto nag 1 hour 30 tayo. Okay. I'll be recording hopefully over the weekend. I'm not sure, no promises. The heat transfer one para meron na rin kayo mapanood. Kasi hindi talaga natin aabutin. Hindi talaga natin maaabot ito in time. Okay? So, yun. Thank you very much. I'll see you next time.